Okay, in this video I'm going to show you basically how to use callbacks to do animations in a really simple way, and then the next tutorial I will show you how to create a bouncing ball and some basic physics. So this first one, I just created an animated object called random turtle. So this is I'm using subclassing here, so random turtle is a subclass of turtle.turtle. I'm not even bothering changing the init method, so in this case, it'll just start up like any old turtle, but I'm adding a couple of methods. It's got an update method, which moves it forward some random amount and left some random amount. And then a tick method, and this is where the timer works. So here, when I say tick, it calls update, which moves it forward and left. And then it's going to call one of the screen methods. I'm accessing. Every turtle has an attribute screen, which is the same. That's the same screen you'd get if you called turtle.screen with a capital S and then a open paren, close paren. So self.screen here is identical to calling turtle screen, just a convenience. It has the on timer. On timer, like on click, takes a function. In this case, I'm giving it the method tick. Could be any function, and it takes a time. The time is in thousandths of a second, so this will wait 1/10 of a second and then run again. So every 10th of a second we call tick. Notice it's no problem that I'm calling tick inside of tick. That's called recursion, that model, and that's just fine. So inside of tick, I call tick. There we run update, move ourselves, and on timer. And then I'm going to create a list of turtles. I create 5 random turtles, and each turtle I call tick on, which starts the timer for each turtle, and then I run the main loop. So if we run this code, it will create 5 randomly moving turtles. And it'll look different every time I run it because they're running, as I said, at random. You'll notice this animation looks pretty jerky. And it's going to be much, much worse if I were to increase the number of turtles. So let me change it to 50 turtles, and you will see that it really can't keep up. And that's because the turtle program's trying to animate everything all the time. And it goes really horribly. It can't do it. Okay. So there's one magic little line which we need to add. I'm actually going to go ahead and add an init method so I can put this line in. So turtle init self. Okay, and then we're going to add this line which is tracer, and we're going to set it to 0. This says setting it to 0 just basically turns it off. Now I'll show you what happens when I do that. When I run tracer, runs super fast, but it draws nothing at all. You might be frustrated by that. Well, look at that. It actually did draw it. I don't know why it. I guess it does occasionally draw. So if I sort of just come back, you'll see it show up every so often. I'm not sure. I thought it wouldn't draw at all. It does update occasionally. You can see my randomness growing. But obviously that's really fast, but it's not what we wanted. So when you call tracer, there's a turtle update method, or when you set the tracer to 0, it won't trace as it goes. You have to tell it when to trace. So I could add a update screen, which would take an interval, and that will simply call turtle update, and then call update, or call turtle screen on timer update screen. I guess it's going to be awkward to give it the interval, so we'll just set the interval here. So we could make that whatever we want. So let's say every maybe 100 times a second we will update the screen. We can make that anything. So I've got now an update screen method. If I call it here, just like the other one, that's going to update the screen and then call itself. So it's going to repeatedly be updating the screen, but it's not going to be. Here we go. So let's go ahead and see how that looks. Now we have a much more smooth animation of all 50 turtles. No problem. None of that herky-jerkiness. I can change the smoothness of it by changing how frequently I call update. So to give you an example of that, let me make it really jerky. I'll make it only come up every half a second. So that is one way to do it. And then on the other hand, if I make it do 1,000 times a second, here's what updating 1,000 times a second looks like. Okay, so that looks pretty good. They're all moving independently, it seems. Each one is being called 1,000 times a second. Python can easily keep up with that when it's not doing extra animations. All right, I'm going to get into much more with some bouncing balls and some physics in the next one, and a little more object-oriented programming. But this shows you the basic technique for animation. Couple key things. You need to turn the tracer off. That's per turtle. So inside of each turtle, turn that tracer off. And then the basic method is you set up some kind of regular update that's going to be called on a timer. I like to call it tick because I think of a clock. Each time the clock ticks, everybody gets updated. And then we have the whole screen is updated, and that's what video game players call a frame rate.